Before I start testing, I do want the console back together and on the bike, which means I need to deal with the wonky and offset alarm panel. My initial thought was to cut off the mount for the alarm panel and make a new one from some mild steel and weld that back in place. But then I realised that I could of course just cut off the old one and weld it back in a slightly different position. After removing the freshly applied powder coat, I used a junior hacksaw to keep the width of the cut as fine as possible and cut it off. When welding it back on, I offset it by about 3mm to the right and also rotate it slightly to the counterclockwise direction by approximately 1mm at the top right corner. I first do a couple of tacks and then check the fit. It looks so much better, so I complete the weld on this side and add a couple of beads on the rear, this being a bit more difficult due to the lack of access. After some work with the angle grinder, files and emery, I try it again. I think it's fair to say that this is much better, both in terms of the offset and the wonkiness. The downside being that the fade pattern will now be visible, and I don't know how to address that without risking removing the printed symbols, so I'll have to live with this. I decide not to get the bracket powder coated again. Instead I spray it with some enamel rattle can paint and leave it for a few days to cure before refitting it. I'm not able to fully tighten the collar on the ignition lock, so I'm going to need to come back to that. And unfortunately, with me having fitted and removed it so many times, it's now looking quite scruffy. I refit the sub-loom for the alarm panel, and then working with my benchtop power supply, I test each of the lights from the pins in the connector, noting the relevant pin numbers as I do so. The main beam light is not as bright as the others, but I do try with a couple of other bulbs with no difference. I then fit the other sub-loom for the indicator and internal clock lights and test those too. Before refitting the cover, I tidy up the wiring as best I can using some cable ties. It's worth noting that the mounting bolts need to be put back in place before the internal bracket is fitted, because they won't go in otherwise. And to finish with the console, I can't say that I have any desire to be opening this up again, but I suspect I will need to at some point. Since cleaning and making a temporary fix to the broken flasher switch, I have sourced a replacement. This is a Chinese manufactured double pole single throw switch, and quality may be questionable, but likely no worse than the OEM part. The connector positions are not exactly the same, but as long as they don't foul with anything when the fairing is refitted, that should not be a problem. I fix it in position on the left headlight bracket and connect it to the loom. Rather than using the battery to test the loom, I'll use my power supply. I've got it set at just under 12.5 volts, which will be fine. The key advantage of using the power supply is that its output is current limited, and therefore it's unlikely that any problems with the wiring will result in overheating or damage. I have connected the negative output directly to the negative terminal on the battery because it's convenient, but the positive output is connected to the bike's positive feed that would normally be connected to the battery's positive terminal, and the main feed cable to start a motor is not connected. As a further precaution, I have removed all of the fuses before I start testing. Another advantage of using the power supply is that I can see the current draw as I'm testing. Although my bike does not align with the wiring diagram I have, as I've completely removed and reconnected the loom, I should of course know what circuit each fuse protects. There is space for 6 fuses in the box, but only 5 of them are used. The 6th, or number 5 counting down from the top, is not used other than as a spare fuse holder. I start the testing with the parking lights, which are fed by fuse number 4. The parking lights can be switched on with the ignition on or with the ignition in park. Not surprisingly, both modes do also require the light switch to be switched to park. When on, the dip beam console light and internal clock lights, rear light and headlight pilot light are all on. We can see that the current draw is just over 1.8 amps, which aligns broadly to the load of 24.2 watts. That's 2 5-watt rear lights, 1 4-watt pilot light, 3 3-watt clock lights, and the 1.2 watt dash light. Fuse number 3 feeds the front brake light switch and 4 of the dash warning lights. We can see the neutral and oil pressure lights on the dash come on, and I can simulate both by disconnecting the relevant wiring, first the neutral switch and then the oil pressure switch. To activate the rear brake fluid reservoir light, I short the switch wire to ground. I do the same with the alternator warning light, although for this I'm only proving the wiring to the console, not the function of the circuit that needs to bring this down to ground. I'll need to test that with the engine running. The final circuit on this fuse is the front brake light switch, which I test by shorting the terminals. Fuse number 2 feeds the horn, headlight flasher and the power for the alternator warning light circuit, but as I said earlier, I can't test that without the engine running. Fuse number 1 feeds the rear brake light switch and the starter relay. I'm not getting a very distinctive clunk with the relay as the power supply goes into current limit mode and the voltage collapses, but we can hear that it is being energized. I should also note that this relay provides the power to the starter solenoid, which is built into the starter motor, which itself is not currently connected to the battery, hence the engine doesn't crank. Fuse number 6 feeds the indicator circuits. The flasher frequency is a bit hit and miss as the power supply goes into current limit mode every time the lights come on. This is all the more evident when the hazard lights are activated. I've not covered off the lights yet. These, along with the front brake light switch and dash warning lights, are fed via fuse 3. But as we can see, they're not working. That is just the pilot light on in the headlamp. By working through the wiring, I can see that power is getting to the switch on this red and black wire here, but the output from the switch is not accessible as it's down on the bottom of the switch behind these wires. To access it, I remove the switch from the switchgear housing, and despite being careful, I managed to snap the input wire off the very small terminal it's attached to. This is an inherent danger with working with 40-year-old motorcycle electrics and makes me very reluctant to take these things apart. To fix the broken wire, I solder it onto this little tab, but this does not resolve the issue of the lights not working, so I pull the switch apart. With the internals exposed, we can see that the contact plate in the switch is both dirty and worn. I used some memory to clean it up and then carefully put the switch back together. Here you can see most of the parts, a couple of which are very easy to lose on a dirty workshop floor. After reassembling the switch, I carefully refit it without breaking any more of the wires. With it all back together, the lights do now come on and I can select both full and dipped beam, although I can't, so I'm impressed that one goes off before the other comes on, in both directions. With the lights on, there is a total load of approximately 60 watts, given a current flow of 5 amps passing through the switch. Given the poor state of the wiring, this does cause me some concern, so I am going to need to do something about it. The simplest option will be to fit an LED lamp, which will significantly reduce the current through the switch. That will be a job for the future, and for now I'll keep it as standard. After testing the loom, my plan was to remove it from the bike and finish wrapping it and the sublooms with the mesh and cloth tape I referred to in part 4. But on reflection, I'll now do that after I've tested the charging and the ignition systems. Instead, I'll get back on with the mechanicals and look to get the clutch lever and cable back on the bike and make a start with the fueling system. As always, if you enjoyed the video, please do give me a thumbs up and thanks for watching.